Hello, Professor, and we're back for the final. So, um, as you can see in here, I hope this isn't too loud when I hit it. We got menus. We got a master slider, sound volume, which here it won't matter too much, and music volume. We also have all of these, but until I build it, they won't do anything. So, oh, and just for funsies, they save. Anyway, so menus, how does all of that work? Well, as for the sound, we first we first have to go through and actually make our code do what it's supposed to do for all those. So I have this options field populator script, which when I first made it, all it was supposed to do was populate the fields, and then we had that whole problem, and it just ended up being main menu code, or not main menu, but options menu code. So we have all these variables here. We have to have one for each drop down. For the drop downs, I have my own variables. One's for the current resolution index we're at, the other one's for the selected, and that's used in setting and displaying. The quality drop down, we didn't have to have any because Unity has some nice built-in functions for quality. And then for each slider, we have the volume slider itself, and it's a variable for its current value. So, how does this work? Well, first in our awake, after we make that drop down that you saw with all these options and everything, it just comes like that. You know, option A, option B, we have to populate it. So in code, um, the first thing we ever do is clear the list just in case there's any weird options, anything going on, um, and so that we don't double up on options. And then below that, I make a new list of strings called resolutions, and this we're going to fill with all of the resolutions that Unity has, can find, and it has these saved somewhere in its own libraries. We don't have to go get them. We don't have to make them up. They're there already. So then we're going to do a for loop to iterate through all of the resolutions in this array right here. And to add them as a string, we're going to use the built-in function of list add, and we're going to add it as a string. So we use string.format. There you go. There's the format of the string. And then we tell it what to put into these. So we say we want the screen resolution's width and the screen resolution's height. And it concatenates those and makes a nice little, those texts that you're used to seeing when you're looking at resolutions. Then I have this if statement here, and that says if screen.resolutions.width, and I is just for where we're at in here in the index, is equal to our current, and this is also something built in, screen.current resolution, is equal to that, and same with the height, and screen resolutions index.height is equal to our current resolution.height. Um, that's our current resolution index. So that sets where we are in the beginning. And to be honest with you, I think I still need to write some code that like actually sets this in the beginning, but it'll set it when you load it afterwards. So, um, then for the resolutions drop down, we add. This is where those all actually get added in. This is where they're made. Uh, so we create all these strings. Now, what do we do with them? We add them to the options on the drop down. Now, here is the same thing, but it's a lot easier for the quality drop down. We clear the options, make sure there's nothing in there. And then we just do add options, but instead of doing any fancy stuff, all the quality settings already exist in quality settings in this class right here. So we just say dot names to list, and it just sends them as a string to this list, and that's how you get all their option settings over there. Mine are like low, high, very high, ultra. So then all this does right here, this is code for me. It sets itself as the options menu variable in the UI manager.instance, and then we set ourselves to false so that the menu screen isn't in your face when you start the main menu, or the options menu isn't in your face when you start the game or the main menu or wherever. it deactivates. And that's also why you see it floating up right here. It was just the way I thought of doing it. I'm sure you can set it to where it starts inactive in the scene, and then just do everything programmatically. I did not do it that way. So then we have this function right here called onEnable, and I call my own function that I made in here called load settings. And when it's enabled, it also makes the apply button false, so that people can't be clicking the apply button when they haven't done anything yet. Um, this is just for closing the options menu. It can't. When I was trying to set this function on the UI manager, it was not working. You saw. So that's why I made these functions that just call that function and put them on here. I don't know if it defeats the purpose of having a UI, of having a singleton. That if you have to do that, but it's definitely a lot easier than writing the full function twice. So, um, that's what we did there. And all this does is make the apply button interactable. So we have this on every single option on here that has a value that can change, so that every time you mess with any of the values, the apply button becomes interactable. Um, so this is basically what happens when you click the apply button. Actually, this is what happens when you click the apply button. We're gonna do a bunch of player preps of set float and set int. Um, we pass them in with this key and then the value that we want to save. Um, so we do that all the way down. I even do it with the toggle, because you can convert it to an int to see if it's on or off. So we do that. This set resolution is actually my own method right here, even though set resolution is also a Unity method, like one that's built in. I'll get down and explain that when we get down there, but this is what selected resolution is for. We said that earlier. When you select a resolution from the drop down, selected resolution gets set to that, and then we pass it into here to actually set your stuff. Um, this set window mode doesn't actually need to be passed anything, because it just checks if the full toggle or full screen toggle boolean is, or checkbox, which is really just a boolean. It checks if that's checked or not. If it's not on, we have window mode. If it is on, we have full screen mode. And this is another beautiful built-in function by Unity, making us not have to do any actual work either. All I gotta do is go to quality settings, set quality level, and obviously this will set the graphics quality level of your game, like the anti-aliasing, all of that, the shadows. And we just send it the quality drop-down value. When we hit apply, it'll handle the rest. We don't have to worry about it. So here's that load settings thing I was talking about in onEnable. We go through, we check if each of these player prefs actually has the key. If it does, we get that key. And then this is just the default value. But if it does, it gets that key, and if it doesn't, we set it to some other value. I just put all the slider volumes at 0 because they're set to align with the dB, so they go to -80 and 20. And when they default to max value, it's actually not fun because they blow out your ears. So that's why this is set to 0, so that doesn't happen. With this one, the current resolution index is set as soon as it gets up, but it loads it with also your current resolution as a default value. If it doesn't have it, it just sets the resolution drop down to your current resolution index. So full screen, just had to convert this to boolean, the player prefs int, and that sets that. Else it's set to true. And then with this one, it'll have the value as a default one, but if it doesn't have the key quality preference, it just sets it to whatever yours is at currently. And so this is where all the volumes actually get going. We have an audio mixer in here, which I will get to explaining in a bit. When you do set float, it just basically sets the fader on there, or I guess a fader is also a slider, but all it does is this gets called on the change value of all of those sliders, each of these individually. I was gonna make a single function that did all three of them, but at this point it was just way easier to do 3 super quickly, so I did that. This is called every time a value is changed, it sets the float of the audio mixer um, with the name master volume. Well, when I say setting the float, it's really setting the decibel value um, of the fader that's in the mixer to volume. So it finds this. Oh, we have this channel called master volume. I'm gonna set it to volume, and then we also set our current volume to volume so that we can save that later. Um, it's the same for all of these. They're just different channels in the mixer. So not really gonna go through explaining that too much. It's exactly the same. It just looks for a different channel. Um, this select resolution is also set on the on value change. Um, I didn't think it would work when I made it like this at first because I thought it would just go through when you have it, but it seems to work just fine because I changed all of my resolutions and it worked beautifully. So yep, all this does is change that variable that we have in there, the selected resolution variable, to whatever the resolution dot drop down value is. Um, it and then that's when it gets passed. When you hit the apply button is when it actually gets passed in and it actually changes your resolution. Um, so you don't actually like change it and then have your resolution change and then you change it again and then you hit apply. You have to hit apply for it to actually change your resolution. And then this is where the resolution actually gets set. And all we do is uh, make a new resolution here called resolutions, the new object of the or struct of the resolutions class. Um, and we pass it in a resolution index to get like what our resolution is that we have out of it, out of the array of resolutions, because this basically gets this set resolution as you saw earlier, it gets past selected resolution, even though it's called resolution index right here. Um, and boom, we make a new one with that. We set our screen resolution with it using the actual Unity method here. And then I also just set the current resolution index to that one for saving when we save our stuff, just to be sure it's always the same. And then here's that set window mode. The set window mode was really easy. I know I have else if in here, but I could probably just do else. Um, but that's not the point. The point is, it works. So we have a full screen toggle dot is on. This is included in toggles, when you have like a checkbox or something. So if it is on, if it is checked, full screen mode equals full screen mode dot full screen window. This is that full screen. I don't know if it's the borderless window, but it's just full screen, and this will just send it into a window mode. Same thing, screen dot full screen. You got to call this and set it equal to one of these full screen mode dot values, just so, or maybe those are properties, but just that's just how you get it to work in my research. So this will change it to window mode if this is off, and this will change it to full screen mode if it is on. Super fun, super easy. I don't know if I should build it. I'll build it right now. Just to show you the resolution changes and stuff. The sound, I'll go to the test scene later for like well, I'll just go in and play it from here. So we got our options and our music. Now this could be changing the full value, but I'll show you that it doesn't in a little bit. I'll show you that these are actually two different things that it's changing. It's just I only have music right now. As for the resolution, I'm still getting a little bit of weird things. It's populating the list multiple times for some reason. Not really sure why, but we can go to this really terrible resolution, set our graphics to medium and make it a window. And there we go. Then if I wanted to, I could set it to like there or there. I'll do full screen so it's more recognizable. Oh god, those all look really terrible. Okay, so there you go. The graphics quality and this are both stuff that happens behind the scenes on Unity. Um, it's nothing too much that I coded besides the actual setting of the resolution. With the function call, I don't know what that function call does exactly. And same with the graphics quality, because when you change this, the anti-aliasing gets changed, the shadows get changed, the textures get changed. Um, so it's all just there. So really quick, you can hear we got forest sounds and stuff going on. Just to kind of show you that those work. The machine gun doesn't have a sound effect, but the shotguns do. Um, they do some weird stuff with the blood, the shotgun bullets, but there's some blood going on. Anyway, oops, and I have this problem too. Apparently the way that I switch when they get destroyed, the missing object doesn't actually get replaced. It just still says missing, so this actually doesn't work if you leave it for once. I'll have to figure that out later, but it's due today, so this is what we got. Okay, so I'm gonna go explain this mixer. Mixers aren't actually like in your scene. They're these objects over here. So if we want to go over here, um, here's each channel you can see. There's a snapshot, which I don't have any. Um, but here, just get us a little bit more real estate. If you look over here, here's our three separate sliders. So I'm gonna hit play over here, and you'll see the music is running through the music and the master. That's because the sound and the music are both children of the master, so everything eventually comes out the master. If I go into here, you can see the master's fader is changed when I change this value with the coding that I showed you earlier, and then the music's fader is changed with this value. And that's all that's doing when it does set float, is it's changing that fader value. We can hit apply if we want or not because it doesn't matter. So I think I explained that. This just goes and finds the channel with this name, and it sets its value to whatever you pass into it here. Pretty easy, pretty simple. All you have to do is actually get this component, and you're good to go. Okay, so I think I showed those ambient sounds really quick, and stuff. Let me go over to my project. We're gonna go to scenes, and we're gonna go to level 1. These ambient sounds are not actually in 3D space, especially with the spatial blend set all the way over here. They are objects like on the scene, but since they're 2D space, they're not registering how like a 3D sound would. They don't have the same amount of drop off or anything like that. Um, and I know that a lot of games have the main audio on or the listener on the camera. You can't see it because he's not in here yet, but my listener is actually on my pawn set right by where his ears are. So when you move away from gunshots, they get quieter and all that good stuff. Even though it would if it was on the camera and the camera's following you, you still have that height on the camera that affects how things sound. So I put it on the player instead, so that the player would be closer. So like a gunshot, if you were to anyway, these three sounds that are located in 3D space, they will get louder as you get closer, further on any sort of axis. Um, these ambience and music sounds are not located in 3D space, especially with the spatial blend. it's treated as a 2D sound right now. If I were to drag it all the way over to 3D, I bet you since the music is sitting, oh wow, whatever crazy spot it's sitting in, same with the ambience, it would get quieter as you moved away from this sound, and we don't want that. We want it's supposed to be all around you, but the object has to be in the scene. So, I mean, some people get around that by putting it on the main camera, but you can also turn down spatial blends and stuff like that to get it to function as a regular sound. Like, not as a regular, but like as an ambient sound. Um, so, next on our list of things to do is particle list. So I actually didn't get the muzzle flash working correctly on the pistol. I don't know what it was about that. Um, but if the speed was at 0, it did not want to exist. Um, it might still be on there. I'm not exactly sure if it still is on there, but I made this. Oops. Now it's gonna come back up again. Apologies. I made this really bad fire particle effect, and then the particle effects for blood too on hit. So I actually don't really have. I have one for my warp core too. It's probably not gonna drop, but there's no code to it. It just plays on Go, and it's actually I need to edit it. It's really bad. But anyway, those are most of my particle effects. Um, so um, we have those particle effects, the blood, and the blood is just on enemies. Yeah, I thought something was weird. The blood is actually just sitting on the enemy and the player. They have different colored bloods, um, and it just plays when on your on damage function. So if I were to click on him and go down to on damage, we have pawn.bleed right here, um, and all that really does, I get the particle effect, like the actual variable, the actual place in memory is on pawn blood particle. Um, but on humanoid pawn is where we put it into use. So I have this public int bleed amount, and this is basically what you throw into emit to get it to emit particles. Um, and down here, that's all bleed is. If we have a blood particle system, blood particle dot emit bleed amount. So it just shoots out, and I think I have it set to something crazy like 1,000, just so that you could really see it, and because it was funny. Um, so when you take damage, it calls this function, checks to see if you have one, and if you do, it tells it to emit however much is in here. So that's why you see like massive lakes of blood coming out of everybody when they get shot and all that. So yeah, that's what happens there. So explaining this a little bit, I have the lifetime set to 1 to really short, so it doesn't really hang out on the floor for too long. And if it's longer than that, sometimes it drags against the floor even when you have the gravity, or not the gravity, but the dampening for the collision set to 0. So let's just go through this. Um, I left the duration the same. The start lifetime is 1, so it's really short. It just kind of goes away after a little bit. Um, its start size is really small too. I figured out to get like a liquid look, you have to have really small particles and a lot of them. So that's why that exists. We have no rotations going on over here. I didn't mess with the start color because that didn't seem to change anything with my material or whatever. And the simulation, the gravity has to be, I set it to 6 because I wanted it to fall like really fast, I guess. 6 was kind of just an arbitrary number above a certain point, so it fell to the ground faster. There's no real reason why it's 6. I just put that in there. Um, and then, but it is set to world space, because if it's set to local space, it'll like follow you around as you run around. So like the muzzle flash should be local space, if I could get that to work. But because that way when you flash your gun for the 1 second that it's up there, it won't like stay. where it instantiated at, or where it emitted it from. When your character shoots, it'll like follow them. But this is world because it looks weird when your blood follows you around after it leaves your body. The simulation speed is 1, just because that was a fine speed in my opinion. Anything slower, it looked weird. I could have put a curve on there, but I did not. Um, and then the only thing else that matters here is that we don't have it on play on awake. Well, and the particle size. I did ramp that up. But if it plays when it's on awake, we don't want anyone bleeding when they spawn in. I see a mission is checked here, but I had sworn that I checked it off. So maybe that's why it's being weird. Um, but because we emit through code, we don't need it on here. The shape is just a cone. It's turned. I I think I rotated it 90 degrees, which really wasn't necessarily. I could have just changed the way that it fell with like velocity or something like that, but I didn't do that. So it's a cone shape with a really tight angle and radius. The thickness is still the same, and that's to get it to kind of just like stay around your body a little bit so that it's not actually coming out in a cone everywhere. It looked weird when I did that. Um, I have a velocity limit over lifetime because I was trying to get it to stop hitting the floor. But then I left it on there because it looked good and I didn't want to mess up the animation. This noise is on here so that we get like these random spurts, sort of, when you get hit, so it doesn't always come out exactly the same, even though there's so many particles that it doesn't matter anyway. Um, but this just kind of adds like a little bit of extra spurtiness to it. They'll randomly come out in a direction. This collision, it's set to world, so it collides with like my terrain and everything like that. The dampen is set to 1, so that when it hits the ground, it stops. We don't want it bouncing, obviously. I didn't have it lose lifetime faster because it already disappears fast enough. Um, and this also messes with speeds, which as you see when it hits the ground, it kind of stops anyway, so I didn't mess with that. Basically, all that mattered here was that collision was on and it was set to world, so it collided with stuff in my world. Um, and that is all I did besides make this blood material, which, if I go into art and I go into materials and particle materials, you can see I have an alien blood one. Yeah, I chose that one. It was some menu thing, but it ended up looking really cool. And then we have the regular blood one right here. I chose like a kind of metallic color because I assumed blood captured reflections, but it ended up looking like pretty nice anyway. So even if that's not accurate, that looks good enough. The alien blood, as you saw when I got shot, it's the same thing. It's just this item, alien blood, sitting on here. Ignore footfalls. I was gonna have the foot sound, but I figured out I had to redo all of my animations, and ain't nobody got time for that. So this is also up around the chest. So when you see it, when it goes, which since we don't have emissions on, it won't go. Um, blood comes out from like his chest area, and you saw it in there. And this is almost the same. Actually, this is exactly the same with just a different material. Same thing, different material. Um, just so that the alien had like alien blood instead of him bleeding human colors. I thought that would be cool. Um, and it's on the same bleed. There's just a different particle system put into the variable. So people can bleed sparks if you want with how this is set up or anything, and it's public, so it actually can be changed, and that is on purpose. Um, so what is next? Next is the lighting. I don't have any reflection probes in my forest level, obviously, because even the ship, it didn't have too many reflective surfaces on it, so I didn't see any point. But here I do, and I'm not gonna even go into the game mode because this is this suffices. So we've got these reflection probes here. If I go into the scene hierarchy over here and I select this reflection probe, we can see that I chose a custom bake type. Um, so it would make like dynamic objects and stuff. Um, and really here, all you have to do is change the resolution if it's like a bigger mirror, like if it's like an actual mirror that the players can look into and see their own character, you're gonna want to have like a good resolution on it. This one has a lower resolution, but it's fine because it's such a tight ball. See how it doesn't matter. Um, these ones, on the other hand, it did not. I put these in different areas to kind of just see how mirrors worked, and look at that. That is not what I expected. So, maybe there's a better way to do this, but I mean it works still, you know. If this was a first person or something, even if we came down this hallway though, we'd be like, wow, that looks really weird. So but it's cool. I put them here just to kind of test to see what it would look like and do. And I figured it out. So those all have higher resolutions than the one you just saw. Um, and really, after you put the light probe, I put all these light probes right on top of the objects. What is this? Left mirror reflection. And for these ones, I had to set their box size to really small so that it wouldn't mess with these mirrors too. Because at first, all these mirrors were reflecting the same thing, and it was a little bit weird. Um, but once we changed the box sizes, it was all good. You see, they're reflecting the right thing. And I have one more just because I thought it would be a cool idea, but it actually just blocks your view when you come in this way. The sides look really cool. I don't know why I think that looks really cool, but it does. Um, but I set it to be like a mirror of this because I thought that would be interesting to look at. Um, so I pretty much put all of the reflection probes on top of the objects that with the reflections around them, just so that it would get like what is this one called? Mirror reflection probe. Just so that it would get the the cube map that it generates from the environment, like to a T as possible. I didn't want it to be grabbing something from over here and projecting the cube map on this object. So you kind of want to place those reflection probes like I don't know if you want to do it every time. Maybe you can create some weird mirror effects. You know, it's up to you in game programming. But if you want the objects to accurately reflect their surroundings, you want to put the reflection probe like right on them, so that that bump. I keep wanting to say bump map. So that that cube map that is placed on top of here as a texture looks right, and it reflects stuff accurately. Um, and this one was a really nice one, honestly. That was perfect. I put that light there just to see how it would reflect the light, and the answer is it doesn't matter too much. So, yeah, I just put those in different locations just to kind of see what they would do, see how they looked like, um, and see what it would look like when I went up to them. In the top-down setting, all of those suck. You can't really get a good look at these side mirrors at all. So if I was gonna make a top-down set game and have mirror-like objects, they would all have to be mirrors that I don't know, do stuff cool with the camera, because if it's perpendicular to the camera, you get this weird bat when you're playing, and I can't even tell it's a mirror. I don't know about you, but so when the camera's like here following your character, those mirrors kind of suck. But if you were to lay one on the ground and have your dude walk on top of it, that might be cool for like a level effect. If you wanted to show like a shiny floor, you could do you could make a surface a little bit reflective, so it's just a little bit in there. Looks like it was polished. Okay, sorry about that. Kids being crazy. All right. So FPS counter. It says it's got to run smoothly at 60 FPS. SPF. FPS. We're not blocking sun rays here. So there's my FPS, I guess. I don't know if this matters with what machine you have on. It's running smoothly at above 60. Oh, there we go. I've dipped below 60. So I guess I need to optimize my code a little bit more when more people get up on here, as it lowers dramatically the more objects that are in the game. But it runs smoothly, I guess, for what it is. So there we go. There's that. And my build is actually available on my itch.io page. Um, whoops. If you go here, oh no, that didn't load how I wanted it to, but it's there. I'll edit this theme and stuff a little bit more later, but this is it. So it's up on there when you want it. All right, it was a fun class. And I'll see you later.